Okay, well, we're going to go ahead and get started. Welcome everyone to today's webinar on an assessment of an energy management information system with automated system optimization. Before we get started, I'm going to review just a few webinar logistics. Today's webinar, you will all be in listen-only mode, and you can submit questions by using the Q&A panel on the bottom of your screen. And you don't need to wait until the Q&A session at the end of our presentations. In fact, we encourage you to submit questions well in advance of the Q&A session. Today's webinar is based on an evaluation by the National Renewable Energy Laboratory, and you can find the full report as well as summary documents on gsa.gov. And we'll also be posting links in the Q&A panel. Today's webinar is being recorded and it will be shared. You can find presentation slides and recordings for all webinars on our webinar page at gsa.gov. And you can also access all the webinar recordings on our YouTube channel. And with that, I'd like to turn it over to Kevin Powell, the director of GSA's Center for Emerging Building Technologies.
Thank you, Andrea. So I want to say, first of all, we are definitely consumers of innovation here, as well as leaders of these field validations. We're actually coming to you from a new facility here at GSA, our Workplace Innovation Lab, which has not been without its hiccups. So that's kind of, I think, a good metaphor for how projects go. This project is incredibly exciting to us, and it's exciting for any of a number of reasons. But in particular, and I guess you could say, spoiler alert here, this technology performed well. We think it's going to be, that is to say, this energy management information system with automated system optimization, as we call it, it's going to be a key tool in our net zero building tool belt. In terms of our agenda, what we're doing here today is I'm going to offer some just brief remarks, put this in broader context. Our PIs will then present a more detailed account of the results from the field study, as well as an analysis of the broader potential for this technology in terms of national deployment. We'll then hear from our GPG regional program managers, a couple of them, who will offer some more boots on the ground perspective. And most importantly, we'll really save some time to answer your questions. So next slide. You know, it's sort of I guess you could say very timely to have this meeting today, because it's really just about 30 years to the month that I met with Steve Salkowitz, who was director of building technologies at that time at Lawrence Berkeley Labs. 1992, way before our time of iPhones and so on. And Steve outlined a vision for a smart, connected building of what could happen if all of these different systems, instead of being individually optimized, could be operated as a system. And the numbers that Steve and other colleagues at Lawrence Berkeley Labs formulated 30 years ago are what we're validating today. So at that time, it seemed like this was way out in the future. The future is today. So that number is, as we looked at the high end, was 30%. We thought on an everyday kind of basis, we could easily achieve 10%. So that's kind of how we looked at it all that time ago, and that actually is something we'll get to talk about today. Next slide. Just to, again, point you to our website where you can find this. It's at gsa.gov/GPG. You'll find this summary report as well as all of the detailed information that sits behind it. Next slide. Also want to say this was selected for the joint program that we have with Department of Energy. And so therefore there's a separate site, there's a commercial building site that was done through the DOE program. So that's our HIT Catalyst site. And what's again important is, and the reason we do these, so it's not just in federal buildings, this is looking at this technology across the broader commercial real estate sector. Their results were similar, actually give us great confidence in our own results because they really do map to them. And as you can see that on this slide, savings were less at that particular site because the runtime was shorter. We mapped it to the same run times that we operate our buildings with. We actually see really, really similar results. Next slide. Lastly here, it's important to note that this is a cloud-based solution. As such, it needs to be going through FedRAMP. We did this under a provisional authorization to operate, authority to operate, but more broadly, this would need to go to a FedRAMP solution. What's really important about what we did do in terms of that initial authority to operate is that it gives us a lot of confidence, and it gives the vendor a lot of confidence that this can transition to a FedRAMP authorized solution. Next slide. So with that, I'm going to turn this over to a couple of our NREL colleagues. Just a couple of notes about them. Allison Kant is a senior research engineer at the National Renewable Energy Lab. Allison supports new technology demonstrations and deployments aimed at testing innovative building technologies in real-world applications and enabling deployment of the most promising ones. Sean Pachuta is a research engineer of energy management information systems and building analytic software initiatives at National Renewable Energy Lab. Sean supports energy optimization projects through data analysis and automatic fault detection and diagnostics. And with that, I'll turn this over to Allison and Sean.
Thanks for the intro, Kevin. I'm going to provide an overview of the technology that we tested, which is an energy management information system with automated system optimization. So this is quite the mouthful. The acronym for it is EMIS with ASO, which helps shorten it a little bit. And EMIS with ASO aggregates historical and real-time data with machine learning to dynamically control and optimize building performance. The system extends EMIS functionality beyond the one-way communication used to identify energy conservation measures and perform fault detection and diagnosis to two-way communication and automated system optimization with the building automation system. The system continuously analyzes data from the BAS and other data streams, such as weather forecasts, outside air temperature, indoor air quality, occupancy, and other sources to optimize performance while maintaining occupant comfort. Next slide, please. So the technology that we evaluated in this project was provided by Prescriptive Data, which offers a modular software as a service EMIS with ASO solution called Nantum. There are three Nantum products: Nantum Core, Portfolio, and Tenant. Core and Portfolio were tested in this evaluation. Nantum Core was implemented at 4 facilities, and Nantum Portfolio was implemented at over a dozen facilities, with integrated AMI and limited BIS points at these portfolio sites versus the full BIS integration for the 4 Nantum Core sites. We'll talk in detail about the test sites and findings in the following slides. There are 4 capabilities that we evaluated. Occupancy counting technology is the primary capability that informs and enables the EMIS with ASO. The occupancy data is used along with thermal modeling, weather data, and machine learning algorithms to implement the ECMs, or the energy conservation measures. So this is things like optimizing air handling unit fan startup scheduling based on when people are arriving and when is the optimum time, and then ramping air handling unit fans at lunchtime at the end of the workday. So kind of reflecting the change in occupancy pattern during the day. The EMIS with ASO machine learning capabilities are also enable predictive analysis for daily peak demand. So this allows operators to make informed adjustments to mechanical systems to reduce peak demand charges. The EMIS with ASO provides the ability to view similar data across multiple buildings via a portfolio-wide dashboard. And this is what we tested with the over a dozen sites in the portfolio test case. Next slide, please. The EMIS with ASO was used to identify and implement optimum start time for air handling units based on interior and exterior conditions and historical data, as well as mid and end of day ramps based on occupancy. So in this sample figure, we see a sample base load. So this is kind of the business as usual case. This is indicated by the thick blue line. And then we can see the calculated optimum air handling unit start time and mid end of day ramps. This is indicated by the red arrows. The resulting energy savings is reflected by the area under the blue baseload and the optimized, or the area between the thick blue baseload line and the optimized load, which is the thin teal line. So not analyzed in this assessment, the prescriptive data system can also optimize demand management to reduce time of use charges. Green Proving Ground is currently evaluating this capability as part of a Grid Interactive Efficient, or GEB, test bed assessment at the Foley Courthouse in Las Vegas, Nevada. So now I'll turn it over to my colleague Sean to dive into the details of the test sites, the performance metrics, and the findings from this study.
Thank you, Allison. And for this study, we evaluated 4 different sites, and there were different characteristics about each building or site, which is why they were chosen. So that would be the Austin Courthouse, Dallas Terminal Annex, Harvey Wiley, and ATF headquarters. So just a little background on some of these buildings. Austin Courthouse, it's a 10-story building, and it was chosen because courthouses make up a lot of GSA's portfolio, a significant percentage actually. This is also somewhat new construction with multiple different technologies: chillers, boilers, crack units, air handlers. And it also has a Niagara BAS, which is on the more sophisticated end of building control systems. However, there are many different options out there. Dallas Terminal Annex. This was built in 1937, so an old building, but after GSA took it over, there's around $7 million in renovations. The characteristics regarding this building and the mechanical systems: there's 3 different chillers, air handlers with VAVs, and it's an office building. So that type of setup is pretty typical in office buildings, as well as GSA's portfolio has a significant amount of office buildings. For Harvey Wiley, we have a high EUI, and this is 40% labs, 60% office. However, the air handlers, they're separated. So the offices are controlled, or the climate is controlled by certain air handlers, and the labs are other air handlers. So in this study, which I'll go into in a little bit, we focus just on air handler savings for Harvey Wiley. And there's also 1 single tenant in this building. The ATF headquarters, it has a cool little characteristic that it meets most or the most stringent blast requirements. And it's certified at the silver level of U.S. Green Building Council leadership in energy and environmental design rating system. This also has underfloor air distribution systems, which some buildings in GSA's portfolio have this. So we wanted to explore what the EMIS with ASO, or the vendor's product, could do for that technology. Next slide, please. So each building had different features that were implemented, as well as different BASs, different amount of points integrated. And these features were dependent on how the buildings were being evaluated. So some were whole building energy savings, some was fan energy savings, and then all 4 of them included a peak demand prediction, which is a feature within the software that was installed in these buildings. There's 2 different types of occupancy counting sensors that were involved here in the project. So 2 buildings had density sensors, and 2 buildings had forward-looking infrared radar sensors, or FLIR sensors. And for Austin Courthouse, Dallas Terminal Annex, we did whole building savings. And as I said on the last slide, for Harvey Wiley, we did air handler savings only, which segues good into the next slide. So next slide, please. These are the performance objectives we defined for the project, and they include energy savings, peak demand prediction, cost effectiveness, the integration and platform functionality, as well as GSA link compatibility. So we defined success criteria with the vendor going into this project beforehand: whole building energy savings of greater than 5%, AHU fan savings of greater than 8%. That's just for Harvey Wiley. Peak demand prediction, we wanted that to be within 5% of the measured electrical demand. A cost effectiveness payback of 5 years or less. We wanted to integrate at least 2 third-party systems into the software, as well as create a successful link to GSA Link, which is SkySpark. However, some of these processes, as far as how we were measuring them, were drastically changed during the project due to COVID. And we'll get into that in further slides. Next slide, please. For qualitative performance objectives, this was how the product was evaluated as far as the usability and people's opinion, as well as ease of installation. So we evaluated 3 different categories here: single pane of glass or portfolio view, which would be you're looking at a bunch of buildings in a portfolio all on one page. You can click into each building based on certain KPIs and do further investigation. And for this, we did focus groups and we did surveys where we wanted no aggregate score below a 3. Ease of installation, less than 12 weeks to install the system and commission it. And the ease of installation, we also did a focus group for that, just to gather better feedback. However, it wasn't within the specific success criteria. And operability, again, we did focus group and survey for that, no aggregate score below a 3. Next slide, please. So this is the integration of third-party application systems. This success criteria performance objective was successfully achieved here. Everything on the slide was integrated. They're all third-party systems, multiple different communication languages, and multiple different vendors and technologies. So this was pretty cool. Everything was successfully integrated into the product, and that includes BACnet, IP, Modbus. I mean, you name it, it's integratable to this, or at least for this project, the ones we tried were. Next slide, please. The GSA link compatibility, we didn't have to modify the API at all, and we just had a successful link to GSA Link. So we were able to prove this at the Dallas Terminal Annex building and able to import data from the software into GSA Link or SkySpark, which was shown on the last slide there. But yeah, those are just 2 quick performance objectives, successful connections there. And next slide, please. So this is somewhat what I was talking about when I was mentioning the evaluation process change due to COVID. So COVID-19, as many people may know, had a drastic impact on buildings. We had a change in occupancy as well as codes. So we needed to make sure enough outside air was getting into the building for occupants that were still going into the building at the time. And we had to transition from an evaluation of looking at real data and what the product was doing to a modeled scenario where we were comparing modeling to the results of what the software was doing with certain inputs, which made this highly accurate, actually, which is some pretty cool stuff, and just proves some of different technology, how models can help with this, as well as how successful the product was with able to input different types of data. So here, these are the results. Austin Courthouse, we had an 11% reduction. Dallas Terminal Annex, we had 5.1% reduction, and that is in whole building savings. For Harvey Wiley, the fan savings we found were an 8% reduction. And just a little bit on the process, the occupancy sensors, they were installed prior to the COVID-19 pandemic. And actually the curve of the occupancy stayed the same. So it was just the amount of people that were reduced. So the times that people were entering the building and leaving the building was all the same, just it wasn't as many people. And so we used that information to input into the vendor's product for the what is it, the optimized start and stop times, as well as the midday ramps and the end of day ramps. And that is where a lot of savings was found in all three buildings. The Dallas and Austin Courthouse results were based on open studio models, and these are used and involved 2019 utility bills. These bills were broken down to the hourly level in these models. So there was just as accurate as you can get. A lot of the times with modeling, they're broken down at the daily level. And so this was pretty precise for this project. For Harvey Wiley, we did the savings in Python, calculated against the 2019 baselines there. And we grabbed manufacturer fan curves as well as horsepowers of fans and a lot of BAS data to accurately model those. So you'll see higher savings in Austin due to a higher EUI and some retro commissioning issues initially. So there was room for more savings. Dallas had a pretty low EUI. It was about half of what Austin Courthouse had. So you see a little bit lower of savings there. They also had 24/7 chiller needs, so that never turned off. And Harvey Wiley was right in line with expectations. So these performance objectives, this success criteria was set by us and the vendor going into it as far as what we and they thought we could achieve. So that's why you see those numbers being pretty close to the success criteria I previously mentioned. Next slide, please. Terminal Annex results. This is just a chart on some of the savings that we saw and the categories we saw the savings in. You'll see there is an increase in pumping or no savings in some months, and that is due to a reduction in fan usage. And for this building, it's a hot and humid climate. And what happens when you reduce the fan usage and runtime by a couple hours is it changes the thermal load of the building, which increased in a peak demand. And the vendor is actually taking this information and hopefully adjusting their algorithms. It was in a lessons learned and recommendations. So they're open to feedback. And that was the only interesting part of the project we saw where we didn't see savings. And hopefully adjustments will be made, and hopefully we can give you an update on that moving forward. But as you see, significant savings in AHU runtime and cooling here. Next slide, please. Austin Courthouse, again, you see significant savings for fans, cooling. There are chiller savings. They're just not seen on this graph due to how we did modeling processes. We couldn't include it on the graph, but you can find more of that in the report. And you'll see a higher savings here on this chart because the building's more modern and it has variable speed drives on the chillers as well as variable frequency drives on fans and pumps. Next slide, please. The peak demand performance objective. This was very impressive. And Allison had previously mentioned the GEB project we're doing. And this feature of the software actually inputs into one of our performance objectives for our next project evaluating this technology. So we did a 2 one-sided t-test here, and we found 98.5% accuracy for Austin Courthouse, 97.5% accuracy for Dallas Terminal Annex. And this compares the peak demand of the day, the measured peak demand, against what the product predicts in the morning of that day. And we found high accuracies at all buildings. Next slide, please. These are the other two locations. ATF headquarters, you have 95% accuracy, and 96.5 at Harvey Wiley. And Harvey Wiley, we had, I think it was a power outage that caused some of the servers to go down. So you see a data gap. However, that was not at the fault of the vendor. And it was on the IT end where we had to fix that to get data flowing again. And it just proves that this is even more accurate, in my opinion, because it's a lower sample size. So if you have one reading that's off, where there's a random day where it's super cold, and the weather might, throw a wrench in the loop, it has to be accurate because you have a lower sample size. So impressive results there. Next slide, please. The cost effectiveness, we wanted this to be within 5 years. And unfortunately, due to the low cost of energy in Texas, this was not achieved. And as you see, annual SaaS fee exceeds savings here. However, when we ran the analysis, the simple payback analysis, on the GSA blended rate, which is an average of 11 cents per kilowatt hour, versus the Dallas Terminal Annex had almost half of that as far as their price of energy. So it just shows how cheap some of the Texas energy is. 11 cents, Austin Courthouse did see a 4.84-year payback. And this, in the middle of the project, actually sparked a market analysis, which was run on all of the GSA buildings, which is the next slide here. So next slide, please. And the market analysis, we did not include installation because a lot of buildings have different costs and it's really hard to gauge how much it's going to cost. If you're looking at a sophisticated building, you might just be able to kind of plug and play and integrate this, versus other buildings might need meters to be installed, occupancy counting sensors, and you can just, increase costs depending on the lack of sophistication in the building, right? So we focus only on where we see positive cash flow with an annual subscription cost or SaaS fee of 10 cents. And so we took blended rates of energy for all the GSA buildings and what potential savings you might see as far as 5%, 7.5, 10, and 12.5. So out of all 504 GSA buildings, if you were to receive 5% savings from the project, 90 of them would see a positive cash flow as far as SaaS against savings. 7.5, obviously it increases to 223 and so forth. When you're looking at 12.5, you are looking at 424 of the 504 buildings. However, there are many different buildings, many different technologies out there. And this study was just, kind of a blanket study to see if we can increase savings to about 12.5% or 10% for all buildings, how much we can really make an impact financially, as well as carbon reduction. So next slide, please. For deployment recommendations, this product, and it could be cost effective, and we can install it in other areas. However, we might want to test it in areas where there's higher EUIs and higher energy costs, because as we saw, the cost effectiveness for Texas wasn't the greatest, but that doesn't mean that it's not going to make large impacts somewhere else where energy is not as cheap, or where EUIs might be higher, buildings that are inefficient for whatever reason. We also want to see retro commissioning within probably about the last 4 years. And that's just to make sure that you're not kind of having that thought of garbage in, garbage out, because this is a software system. We want to make sure that the data being input into it is accurate and correct. And that way it can make accurate and correct decisions based on that data. So if you don't have accurate data, kind of garbage in, garbage out. So we want to see retro commissioning within the last 4 years, making sure the building has good sensors and good operability. And obviously, this is a good candidate for advanced smart building technologies to couple with some of those systems we had integrated: automated lighting controls, variable speed drives, plug load controllers, and batteries are also mentioned there because that's a cool technology. Maybe we can shift some load, and we will see in the GAB evaluation coming up with demand management. And if that's proven successful, there could be a higher return on investment there as well. So next slide. I'm going to hand it off to Tyler Harris and Joshua Banis, and they worked on this project with me. It was very nice working with them. And just to give a little background, Tyler is the Energy Management Officer and Director of Energy for GSA. He's led GSA projects in innovative areas and installation of grid interactive efficient building technologies, or as you may know, GEB, and a push to purchase 100% renewable energy. And actually, this project took place in Tyler's previous role as Deputy Director for GSA Center for Emerging Building Technologies, and he helped the GPG, or Green Proving Ground, evaluations. Joshua's background: he's currently the lead regional sustainability program manager for GSA Region 7, and he helped manage this project and provided very valuable knowledge base, in my opinion. And next week, Joshua will be joining the Center for Emerging Building Technologies as a full-time program manager. So thanks for listening, everyone, and I'm handing it off to them. Thanks.
Thanks, Sean. So I wanted to talk about a boots on the ground aspect of this project, and we'll start out with installation, and I'll focus first on the 2 Region 7 sites, and then I'll talk about the 2 Region 11 sites with Harvey Wiley and ATF after that. So in Region 7, we decided to utilize an indefinite delivery, indefinite quantity general contractor to install these. And so that general contractor hired subcontractors that were able to do the cabling and the building automation programming that was required to get the system to operate. And so we were able to do this through the holiday season in 2019. And so we had construction teams working through November, December, and we were able to get all this installed. And so January 2020 is when I really became involved in this. And the big thing that we did was we had to work with GSA IT to allow these 2 products to speak with their cloud outside of the GSA network. And so we worked with them to allow that external cloud communication. And once we had that cloud communication done at both of these sites, we considered the installation complete and commissioned. And so multiple sites were used here, and the 2 sites in Dallas, we worked with both of them in tandem. And so we were doing installations with 2 different teams in Austin and Dallas at the same time. The 2 sites in Region 11, we took a little bit different point of view. We did 2 contracts, one to install the cabling and the occupancy sensing technology, and then the second one was to do the programming on the building automation system. Next slide, please. So by training, I'm a anthropologist, so I really like the qualitative aspect. So we did a lot of qualitative analysis in this process. And so a few of the questions that we asked, one was about system integration. And in my opinion, and the opinions of the people that we talked to, system integration went very smooth in Region 7. We did use a BAS contractor, subcontractor that was very familiar with our system. So we have a Niagara front end on all of our buildings. And so they were very familiar with that system and able to program on our wire sheets very easily all the things we needed to do to make both of these platforms work seamlessly. Integration, the hardest sticking point was getting GSA IT to allow the permissions to speak outside of our network. And so once we were able to solve the problem with communication outside of our network, the systems came online and we were able to communicate seamlessly. Cybersecurity, that was the biggest thing. The vendor spent a lot of time going through all of the GSA cybersecurity protocols, and they made it through and made any adjustments that were needed. Contracting, so at the time we had contracting internal to the energy branch in Region 7, and we have a counterpart that's our acquisition team. And so we used internal project managers and our partner acquisitions team to get this awarded, and it was really seamless, and we got it awarded right before the holiday season. One thing I'd like to add at the end about commissioning, so the ML-AI-based OSS and mid and end of day ramps, that occurred after we commissioned the system, and it was right before the start of COVID. And so we developed a plan with government facilities. We always like to be very cautious of any issues that could happen with our tenants. And so in the Dallas Terminal Annex building, we did ramps floor by floor, day after day, adding a floor each day, just to ensure that we didn't have any issues. And then the same thing with the ML-AI based OSS. We started at the beginning of a week and allowed the system to tell an air handler at a time when it should turn on after we had already proven out the midday and end of day ramps. Next, please. So once we had proven out that we could get this technology to work using gateways, so an additional device that was installed at each site, we wanted to test and see if we could do this all on a virtual server. And so we added 15 additional facilities and added 30 points for each facility, all on a virtual server that was created for us. And myself and our BAS IT professional that works in our branch integrated all of these 15 sites. And it took, after we had a small learning curve where the vendor taught us how to do mass uploads of points, we were able to do each building in a few hours and integrate it. So this technology integrates natively with Tritium Niagara 4 and Schneider EcoStructure, and it really doesn't need any hardware installed. So faster installation for facilities will occur where the meter and sensor data is already integrated, and it's as easy as downloading the points and then verifying the point name structure and then putting them into the program, and then they start tracking. Next.
Yeah, so one other aspect that we looked at was the qualitative feedback related to the single pane of glass. And at the time that this product was running within Region 7, I was actually serving as the branch chief for energy and sustainability in Region 7. And so I had a unique need or want to have a product like this work to give a good view of the regional aspects. And as they mentioned earlier, we added multiple sites to this evaluation to be able to look at a portfolio view of buildings, in addition trying to be able to drill down into the individual 4 buildings that were brought out as part of this study, and specifically the 2 that were within Region 7. And so you can see that we had pretty consistent feedback and themes as it relates to the single pane of glass. We asked specifically how well the product helped us track our KPIs, such as energy consumption, and in the individual buildings, but also across the portfolio. And 20 out of the 21 participants, including myself, who was one of the participants, really liked the single pane of glass capability, thought that it was a superior look to what we had available, and especially in the ease of use in the ways that we could use the data. I will mention that probably a majority of the things that we were able to drill into and look at and evaluate are available if you can drill in the right places in the BAS, or drill through the right places into our advanced metering systems that are available, or GSA Link that we have available. However, this brought it all together in a single pane of glass that made it really easy to operate and to view and to drill down. And for someone who was in a management level, and including my other management counterparts who used the system and had logins as well, we were able to really find some really interesting things that I'll touch on in a few slides. So next slide. Just a couple quotes that came out of the qualitative feedback that we received on the single pane of glass is that the O&M was able to pinpoint some specific issues and needs that needed to be resolved. It was a lot quicker than accessing the BAS. One thing that's one of the benefits of a SaaS, there's obviously other things that we could talk about, or a software as a service solution, is that it goes about as fast as your internet speed goes, and it uploads and changes pages, and you can drill in really quickly, and it's just super responsive. So that's one positive benefit to this type of solution. And then the usefulness in day-to-day operations. We had a manager who was out who was in Albuquerque, but was able to view his building up in Gallup, and that saves a lot of time if you can really get a good view of it quickly from a management perspective. Again, without the same technical expertise that may have been required to really drill into a BAS or an advanced metering system. Next slide. So I wanted to highlight a few of from a management perspective, a few of the things that we were able to drill into and find. These are things that we were able to see and use real data on that we had not previously had available, or we would have to ask someone who was a little bit more technical to drill in and try and get some sort of report or data to us. So this is a COVID occupancy look. You can see that we're looking at 2020 March, and we were able to accurately track and manage what our buildings were looking like from an occupancy perspective. Again, all within the tool and in a really easy and simple format to look at date perspectives. We could drill into single days, we could drill into hourlies, and really see how our buildings were being utilized during this transition and what they look like during almost the entire COVID period. Next slide. The other thing that we were able to do is look at some really unique views as it related to our air handling units and our fans, and bringing up some of these unique views that we normally wouldn't have such an easy time drilling into from as someone who is non-technical or not a O&M contractor or a BAS subcontractor. We were able from our view to see some irregularities and bring them up to the O&M. And in this case, we were able to overlay some fan views that showed some obvious signs that some fans were cycling, able to drill directly into these individual fans and see that they were cycling incorrectly, and send those right over to the building manager to have them looked at and corrected. That was, and normally that kind of process would happen the other way, where an O&M or someone else technical would be finding that problem and then reporting it and getting it fixed and getting a work order placed. And that was just one way we were able to find and correct and resolve issues. We also were able to find a water leak in a really similar manner. All of these issues had been long-standing, and these are buildings that had good O&Ms, had GSA Link, had good BASs, were run pretty efficiently and effectively, and we were still able to find things that were long-standing issues because of the easy viewing and drilling into the program that we had. So really impressive results on this standpoint. Next slide.
So a few of the qualitative themes that we received during our surveys was this was able to provide a one-stop shop for all of the building data requirements. And so it gave us a good portfolio view that we were then able to drill down and see each building individually in the platform. Some of the criticisms, however, were the solution did need some enhancements to some of the custom reporting that we had created. And so it was a really good tool, and it just needed a few minor adjustments to some of the custom reporting that we had created to track our KPIs. Next slide, please. So these are a few more things that we chatted about during our focus groups. Rate the usefulness in day-to-day operations over the current practice. So some of the operators said they wish we had this sooner. Definitely an improvement over current practices. Takes the pressure off of running a building. It's impossible to track 30,000 building points. The margin of error is small and the scope is huge. So it allowed us to look at a lot of points, and like Tyler pointed out previously, see some long-standing issues that we just didn't see with our current Niagara framework. So rate the ability to view historical usage trends and create monthly reports. So this was significantly easier to run long-term historical trends based upon the amount of data that we uploaded into the system. So when we started, we uploaded data 2 years previous to installation. And so we were able to easily trend all of that data that we already had in our server, but put it into a graphical format that was easy to view and analyze. And the value of the real-time occupancy data, which we didn't have largely, was immense. So when COVID started, we were able to track how many people were going into the buildings, and certain buildings like Terminal Annex still had floors with high levels of occupancy, and it was great to be able to see that. And then to see when people were leaving for lunch and when people were leaving at the end of the day or arriving in the morning. And so that was really beneficial on an occupancy basis that we didn't have before. And it tracked it live. So I could log into a dashboard and look and see people are arriving at this time, people are leaving for lunch at this time, and people are going home at this time. And so one of the huge comments was, before this technology, we gave our buildings a huge buffer and started our buildings every day at the same time for the worst case scenario. And it's so much easier and better to know that using predictive data, we will hit the temp when we need to. And so we were able to start some of these units way later than they started, just because of historical O&M knowledge. They wanted to be very safe and start them really early in the morning. And then using, especially when we still had the AI ML based OSS started, we were able to let the system start. And then later, when we had to shut it off because of COVID concerns, we were still able to start the building way later because we knew and were satisfied with the data that we had that the building would operate sufficiently. Next, please. So one of the things we've noticed since this system turned off is at the Terminal Annex site, we had about an 11% energy increase in similar situations. And so this is, there's many things that could come into this savings, but I think it proves out that the percentage that we thought in the study and modeled was actually a realistic savings that we would see at this facility. And so similar conditions, similar occupancy, we were still able to see an increase, which probably proved that this technology was saving energy when we had it installed and operational. Next, please. So a few parting best practices and lessons learned. So meet with building operators early on to get buy-in. Some of our O&M were very skeptical that this would actually work. And then the O&M became some of the best proponents of the technology when we were using it, because it was so easy for them to log in, see what was going on, see how many people were in the building, and then make sure on one graphic that all of their systems had started on time and their spaces were to the temps they needed to be in the most critical zones in those spaces. And so some of the other lessons learned: test this at night and on weekends just to make sure the commands work. So the first day we tried to do the ML AI based OSS, the unit didn't start. Luckily, our O&Ms are there very early in the morning and they started the unit. But that was one thing that it was easier to test at night, because if your unit doesn't shut off, you're gonna buy that electricity during the night. But it's much easier to have a unit continue to run at night versus not starting in the morning. Luckily, we have O&Ms that are really great and they're there and they're able to step in when there's issues. And the O&M was very involved, and we had weekly meetings just to go over how the system was working what they liked, what they didn't like, and meet with the vendor to make sure everything is operating properly. So the startup algorithm should account for both electrical consumption and demand, and this will help limit pre-cooling that we didn't need. So that was also a big thing, and it was something that we found that was impactful in Texas during the summer. And so in the summer, we may need to pre-cool, and we can't just start the unit as late as possible. Select an EMIS with ASO that can be integrated with different levels of effort and expense. So in the case of this evaluation, not all sites were cost effective. And so it would be good to choose sites based upon their current operating procedures and how this technology would best benefit them. Next, please.
So we're going to run pretty short on question time, so I'll keep this brief, but we do feel that GEB solutions, grid interactive efficient buildings, really need a strong EMIS solution as part of what we're trying to do, and that is to reduce and shed and shift and modulate the way we use energy. Specifically using an ASO is going to help that even more and make sure that you are flexing your loads at the right time. And so GSA is continuing, just like Sean mentioned, our evaluation of EMIS ASO solutions as a GEB solution. And then also I wanted to mention that GSA is also participating in DOE's Federal Smart Buildings Accelerator program and looking at EMIS ASO solutions as a possible way to get buildings moving in a more GEB direction. So a lot of acronyms there. Hopefully you can read them all in, but that's definitely an initiative we're looking to improve on and do better in. Next slide.
Great, thanks, Tyler. And we did run long, but we also started a couple minutes late, and we're going to keep going. So we're going to go past the top of the hour. This will be recorded, so if you need to jump off and want to come back and look at the Q&A, you're welcome to do so. We'll be posting that recording. So I'm going to jump right in. Kevin, I think this first question is for you. Where can new innovation research be done?
Well, if I think I understand the nature of this question, this would be the moment to really pitch our request for information. So right now you have precisely about 3 days to get in your submission, and you can find that at gsa.gov/GPG. But more broadly, there's a host of programs that both we have, the Green Proving Ground specifically, but also Department of Energy has a number of other initiatives, and certainly encourage you to reach back to us. But this is what this is what we do.
Great, thanks, Kevin. Any battery storage implemented to avoid peak demand thresholds in this evaluation? And anyone who wants to jump in, Allison or Sean?
Batteries were not incorporated as a part of this project.
But those will be part of the forthcoming GEB solution?
They are not a part of the fully building. They may be part of the other HIT Catalyst or GPG GEB tech demos.
Thank you. Is there a standard data protocol that's been established to ensure that equipment, in other words, HVAC, will be able to communicate and share data with the building management system?
This one, there isn't necessarily a standard out there other than it needs to be open. So you heard mention of Niagara or like a BACnet type protocol. I wouldn't say that's the standard across GSA, but it is something that a majority of buildings have and something that we emphasize, especially as we upgrade to new systems. We want things to be able to communicate in an IoT setting and be able to be used across various programs and brought into one EMIS solution such as this. So
great. Thanks, Tyler. Was the cost of occupancy sensing taken into account in computing energy savings? I think this is for you, Sean.
Yeah, so all the costs involved were taken into account for this study. It was just the market analysis where where we removed the installation costs. So the cost to install the occupancy sensors, the contractors that were involved there, and the hours spent, whatever labor hours it may have been for integration, all of that was considered within the simple payback, and could be part of the reason why it wasn't achieved along with the low cost of energy. However, every building is going to be different as far as the cost. And so that's why it wasn't included in the market analysis itself.
Great, thanks, Sean. What were the inputs to the peak demand predictive model, and what type of machine learning algorithm was used? I think this is also for you, Sean.
So the peak demand prediction, it takes into account weather and real-time occupancy. And I think it also takes into account just data, consumption data from each building. However, there is some form of what I believe is proprietary vendor algorithms and how they truly calculate that, which isn't available. But the occupancy sensing data, weather data, and consumption data was all included in that.
Great. And Sean, I think this is also for you. So were HVAC schedules altered, increased in these facilities to accommodate additional ventilation needed to provide more air circulation due to the pandemic?
Yeah, so that is actually like the major reason why, and sorry if I didn't make that clear during the presentation, major reason why we had to switch to modeling. The code changes basically increased startup time and shutdown time like +2 hours on each end, I believe. Maybe was the ASHRAE recommendation originally. And you can't find savings if you're increasing runtime. And so we used the original trending data for the short period we had for occupancy sensing, as well as optimum start stop and ramp down at the end of the day, and people leaving at lunch. And those were all inputs into the model, and the increase in runtime was the reason why we had to switch to modeling.
Great, thanks, Sean. I think this is for GSA, either Tyler or Joshua. So in the future, how is the FDD tool and existing commissioning process going to interact with the ASO? And following up, do you think the superior visualization is a matter of the tool itself, or was it set up? I imagine you have a similar views in SkySpark.
Yeah, I can take a swing at this one. The short answer, especially to the second question, is we do have, I mentioned this as I was speaking earlier, we do have similar views in our advanced metering system, in SkySpark, in the BAS, and in other ways that we're putting our data together. I will say that there was superior visualization in this EMIS, and the ability for us to access it and overlay it and make custom KPIs and make changes on the fly because it was software as a service. And so what does that look like at the future of GSA? I don't know for sure, but I do know that our smart buildings team is looking really hard at it, and they're looking at what we're terming as a unified user interface, a UUI, which is a really similar kind of idea of a single pane of glass, and trying to make these types of views and abilities available to GSA. So I don't know if that fully answers it, but that's kind of the best I can do right now.
Thanks, Tyler. And we'll also be following up with some written responses as well. So how is the demand prediction work, and how are you able to use the ambient temperature or historical weather data to predict the high demand is coming? And Sean or Allison?
Yeah, so I think that maybe was kind of answered.
Okay.
And it's somewhat of a secret to the vendor, I believe, but there's different inputs, and it just predicts what it thinks the demand is going to be. However, we did see, I think it was in Dallas, everything froze briefly, if everyone remembers, and that threw off the algorithm for like a day or two, but then it caught right up. And so it seemed to learn based on weather, but a drastic shift could change it. But I don't know if that is fully true. there's lots of inputs, and it was found to be highly accurate.
Great. Kevin, this is for you. As the coordination with IT took place for the systems to communicate, were there any IT security concerns or issues? Are there any Section 889 supply chain issues with these EMIS systems?
Yeah, that's a great question. And so I guess the short answer to that is that, of course, the supply chain questions would vary vendor to vendor. There weren't with this particular vendor. The sort of the broader question about how to, how these things move through that cybersecurity authority to operate, I think it's opened up, I think, a lot of discussion on our end about what it takes to have a vendor that is FedRAMP authorized and then can have this ATO, and then how do all of these other systems sitting behind it, but that also need to be able to communicate, what does that kind of relationship look like. So it's a great partnership with our OCIO, and I think the sort of the bigger picture answer to that is it's a work in progress. How's that?
Great, thanks, Kevin. We have a number of questions about occupant comfort. And were there any occupant comfort complaints when using ASO? Did energy savings impact comfort?
So in Region 7, we didn't have any major complaints. When we'd have the building managers and O&M staff talk with the tenants, they didn't have any complaints. Although I will say during the early testing phases, we found out that there were some zones that were more critical than others to meeting the temps and for that space in the algorithm. And so there were people that said it's a little bit warmer than usual, but there was no major complaints. And that was fixed during the commissioning process. So once we had commissioned our sites in R7, we didn't really have any complaints that were brought to any of our attention.
Great. Did your algorithms reduce individual AHU VFD fan speeds based on occupancy? And if yes, did you have to disable typical static pressure control sequences? Sean, this might be for you.
So yeah, the software took over as far as supervisory control with whatever their algorithms chose based on occupancy as one of the influencing factors. What was the second part of the question, Andrea?
Did you have to disable the static pressure control sequences?
Yeah, so it would just take over completely as far as sequencing. So if you have the product on, it operates how it wants within certain parameters, which are customizable per location. And then if you turn it off, it would go back to whatever the BAS sequencing said.
Great. We have a number of questions that might be more applicable to the GEP study. So one of those is, can you give an example of how operations were changed to avoid a peak load? And was this automatic by the system or controlled by the building staff? And Allison or Sean, you want to jump in and discuss whether this is part of our next evaluation?
I'm sorry, can you repeat that again?
So how did operations change to avoid peak load? And was this automatic or controlled by the building staff?
So this is like mostly part of the GEP evaluation coming, is what can this product do to avoid peak load? And it's not just there's two performance objectives we're focusing on. It's consistent peak demand reduction as well as a peak load reduction. So if there's like an automated demand response event that the utility calls, like what can this do to reduce the peak load? And so that wasn't focused on in this study. We're focusing on demand in the next study. We just focused on efficiency for this one.
Okay, and this is another question about operation. Can the software support other operational optimization, such as chilled water resets?
I'm not 100% sure, but I believe it might be able to. And that's something that we could ask the vendor. However, the adjustment of air handler sequencing, as you may already know, will and can change how much production is coming in and out of chilled water plants or boiler systems because the need isn't as high. So it can influence other systems. It's not controlling. It just depends on how everything is set up in the building.
Great, thank you. And I think this will be our last question. And for Tyler, as BMS systems point counts increase, data representation is important. This solution seems to have helped getting the BMS data presented in a meaningful way. With that said, how much of the benefits of this evaluation were due to the shortcomings of the original BMS contractors' graphics or trends?
I mean, this is maybe a judgment call on my part, but I would say we don't have a lot of shortcomings at GSA when it comes to how our BMS teams have and what they have available, and that we run a very robust BAS program, have good O&M contractors in place, and we do pretty well with the tools that we have available. So that being said, I think it points to how well this system overlay works to bring all of those together and how much better it can be. And so I would say like we mentioned, we found problems, we were able to realize savings, and I think that just goes to show that there definitely is more juice to squeeze, and but it requires an even more kind of robust solution to make that happen than what we currently have available. And it's not what I would call a shortcoming, because I think that we're really on the forefront right now on the BAS side and with our contractors.
Great, thank you, Tyler. And thanks everyone for those of you who hung on these extra 10 minutes. So we will be sharing a recording, and if you are interested in continuing education credit, there'll be a short survey that we'll be sending out later today, and by completing that, you can request credit. And with that, thank you all. Thank you to all the panelists and to all of you for joining us today, and we'll be in touch. Thank you. Bye.